Alright, here's a puzzle that I solved a very long time ago. It was in an Omni magazine, and they used to have some very interesting puzzles in there. This was one of many puzzles, and it was preceded by an example. And the example was this: it said, what is a half plus a quarter plus an eighth plus a 16th, and so on, 32nd, etc. You can see that the series is 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, on forever, infinity. And what does that equal? You know? Well, this was the example, and it said that the answer was 1. And it offered a proof for that, and the proof that it gave, because I mean it's unsatisfactory just to say that it's 1, or that it's unsatisfactory to say that any problem has a solution x and then leave it at that. No, it gave that as the solution, and then it gave the proof. And the proof that it offered was sort of a geometrical proof. It was a square, one whole square, and the article showed that if you divide the square in half, there's 1/2 of the square. If you divide what's the remainder in half, you then have two smaller squares. This square here is obviously 1/4 of the entire square. And if you take that square and do the same operation as you did to the larger square to the smaller square in the corner there, this piece here is 1/8. You see 1, 2, 3, 4, 5, 6, 7, 8. So 8 of those rectangles would fit into the whole. So you see the pattern continuing. So if you divide that again, the remainder, then you've got a 16th there, which you can see. That little square is 1/16 of the entire. And continue this process forever, for infinity. It obviously converges to the corner. It doesn't go beyond the corner, it can't go outside the square. It just continues to converge forever and ever and ever, getting closer and closer and closer to the whole. But if it went forever, which is impossible, but nevertheless if it did go forever, it would equal 1, because there's one square, and you can see how it's divided up into this in this fashion. So that was the example they gave as a proof that that series equals 1. And that's a satisfactory proof. It was satisfactory for me anyway, and I could see that, and that should be fairly obvious. So then they offered they gave a second problem. This was the problem you had to solve. They said, what is the sum of this series? It's 1/3 plus a 9th plus a 27th plus 3 times 27 is 81, and so on to infinity. So you can see there that the this fraction gets smaller by 1/3. So I mean there's a 3 times 3 is 9, 3 times 9 is 27, 3 times 27 is 81, and so on forever. What does that sequence, infinite series, equal? Now the question was not what does it equal, that's your answer, maybe you're right, maybe you're wrong. No, it was give an answer and then prove your answer. So the question was really devise a proof for your answer. So I fiddled around with this for a while, and I sort of came up with a tentative answer. It seemed obvious to me that the thing equaled 1/2. But I had no means of proving that, so I thought about how to prove that. I tried to do diagrams with triangles, divided into 3/3 or whatever. I don't know what I did. But I couldn't devise a geometrical proof, and I couldn't think of any way of proving it. And it was a hot day, and in the middle of the day I was quite tired for some reason, and I went and lay down on the bed and fell asleep. And because I gave up on it basically, and went to sleep because I was tired. And in that during that sleep I had a dream, and that dream was just one of these magnificent things that happens to people occasionally. It was a total revelation. The dream just showed me the answer to my problem, and it gave it to me just there was no dialogue, there was no explanation beyond what was visually to be seen, which was just total blackness and in the total blackness came rotating into view a Rubik's Cube. A Rubik's Cube. So I'll just draw that. It's going to be important for the explanation as to what happened next. Okay, and then this cube came in, sort of floating into my field of view in my dream, and it just started slowly separating itself. And what it did was the top slab just broke off and moved away. And the top slab of a Rubik's Cube consists of 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces, 9 smaller cubes. But those 9 smaller cubes constitute 1/3 of the entire cube. So 1/3 of the entire cube was taken off from the cube, and all I was left with was 2/3 of the thing. Oops, what am I doing? There we are. What a very good drawer am I? Okay, so there we are, 2/3 of a Rubik's Cube. That's all that was left. And looking at this, then that was one slab, one sort of plane of the Rubik's Cube went away. Then one line of the Rubik's Cube, this three of the smaller cubes, broke off, detached, and moved away. So that line, 3 cubes, consists of, if you see how many lines are there in an entire Rubik's Cube, well, look at the Rubik's Cube edge on, and you see that there's 9 lines of these rows of 3. So 1 row of 3 equals 1/9 of the entire cube. 1/9. So that just broke off and floated away, leaving me with the remainder, which in this case would look like this. Yeah, that's it. Okay, so this is what I was left with. It looks a bit odd, doesn't it? Right. So 1/3 of the cube went missing, then 1/9 of the cube went missing, and then one of the constituent cubes disappeared. Now a dot, a point, so I went from a plane to a line to a point. One of those points disappeared. One single constituent cube of the entire Rubik's Cube disappeared. How do we do that? Is that right? Yeah, that went away. So now that one cube is 1/27th of the entire cube, because a Rubik's Cube is made up of 27 smaller cubes. If you divide a cube equally in this fashion, then you get 27 smaller cubes. So that's one cube went away, one minor cube went away, one constituent cube went away. That was 1/27th. Disappeared. So now the next step was just so beautiful. This is the centre cube of the entire Rubik's Cube. We've taken off one slab, we've taken off one line, we've taken off one of the smaller constituent cubes. What's left is this cube in the very centre of the 27 smaller cubes. The very centre cube of the entire Rubik's Cube is right there. Can I colour that in? I'll try. No. Oh, there we are. That's the centre cube of the entire Rubik's Cube. The one in the dead centre. So now, if we go to that cube and we take away a slab in the same way that we did with the first cube, the original larger cube, we divide that one up into the same way we divided the original one, so we divide that one up into 27. We can't really do it because it's too small, but if you divide the middle cube in the very centre of this Rubik's Cube up in the same way you divided the original one, then you can take a slab or 9 of those sub-miniature cubes, or one slab, 1/3 of the middle cube away, 1/3 of that 27th is an 81st. So you take that slab away, so you go back, you start repeating the same process again, and then you take a line of that away, and then, you know, that goes on, what's that, what's 3 times 81? I can't even do it. But the point is that you get smaller and smaller and smaller, and what you're converging on is the three-dimensional centre of the entire original Rubik's Cube. You're cutting it down smaller and smaller and smaller, getting closer and closer and closer to the three-dimensional centre of the original Rubik's Cube, in the same way as this original example got closer and closer and closer, making smaller and smaller squares down to, approaching the very corner of the original square. This is approaching the very centre of the original Rubik's Cube, getting closer and closer and closer to a point that would be, if it were a point, would be leaving with exactly half. You would have taken exactly half of the Rubik's Cube away and left exactly half behind, if you're able to go forever into the centre of that centre cube of the entire array of 27 cubes. And that happened in my sleep, in my dream, and it was just beautiful, and I woke up elated, and it was just one of those really amazing experiences that I just have been enamoured of ever since. So that's the proof of this series, this infinite series equaling exactly 1/2.